So for our first presentation, I'll be handing it over to Vibhu to talk about Neumarkt.
Thanks, Alex. So we have our first story here. I'll call it a success story. So this is the Neumarkt installation in Bavaria, Germany. So they are a treatment plant which is designed for 150,000 population equivalent. And they have municipal waste coming in along with hospital, brewery, and some food processing industry that is coming in. So the major treatment challenges that they had on site is that they suspected they were getting toxic shocks from the upstream industries, leading to poor removal of total phosphorus on several occasions. The main use of SENTRY here, or why SENTRY, is that they wanted to monitor the fluctuating load that is entering the wastewater treatment plant, identify the toxic events, and make smarter decisions based on SENTRY signal. So the existing tools that they had, which was very insufficient, is traditional monitoring tools like pH, temperature, etc., and some grab samples once or twice a day on shift basis. So we installed two SENTRY sensors, one in the primary clarifier effluent and one in the anoxic zone on 9th of January 2023. For the next 4 to 5 months, we monitored and developed baselines and tried to figure out the weekly and daily patterns on the site. So what SENTRY system figured out is that they had large fluctuations or deviations in consumable BOD portion over the weekends. Let's say the deviation was up to 30% from the mean. As you can see in the graphs below, the green signal has a drop of like more than 30 to 40%. And this was impacting the phosphorus breakthrough is what was identified. And SENTRY signal was giving a 2-day advance warning of the lower carbon that was coming into the treatment plant. So once we figured out that there is this low carbon coming on the weekend, and that is influencing the total phosphorus breakthrough, we tried to identify those drops. So in the graph below, we have week 1, where in green, where there is low carbon, that is leading to phosphorus breakthrough. And week 2 is the blue graph where we started dosing carbon during the weekends. And we dosed 80% of glycerin on the weekend at a rate of around 25 to 35 liter per hour. And SENTRY signal remained in the white zone, or we call it the safe zone. So phosphorus value was stable in the nitrification effluent, and the effluent phosphorus value did not exceed 0.35 milligram per liter when SENTRY dosed, or when we dosed carbon using SENTRY signal, and did not let the signal to drift into the amber zone. So that was the success here. And for the next steps, we continued to monitor the influent for fluctuating loading, and we also try to optimize the carbon dosage based on the incoming consumable BOD. And by doing that, we can save up to 20 to 30% of cost on carbon dosing and have a positive impact on the environment. And the site also realized that these are not really toxic shocks that is coming from the industrial effluent, but just carbon management, and which SENTRY helped them in doing.
That's fantastic. Thank you so much, Vibhu, for sharing that case.
Thanks.
Yeah, and that's definitely something we've seen with many of our clients, is that what they think is causing their problem isn't always the thing that's causing their problem. So it's nice that we can help them pinpoint exactly what it is and then deploy an effective strategy and then evaluate that strategy.